Today we're going to be studying variations within linear equations. Proportionality is the relationship of one variable to another. Now we have two kinds of variations that we're going to be concerned with. There's several kinds of variations, but what we're going to be concerned with is variables that vary directly and variables that vary inversely or indirectly. Direct proportionality. As the value of one variable increases, the value of another variable increases. As the value of one variable decreases, the value of another variable decreases. Also known as direct variation. Inverse proportionality. As the value of one variable increases, the value of another variable decreases. As the value of one variable decreases, the value of another variable increases, also known as indirect or inverse variation. Now the K stands for constant. I know constant is spelled with a C, but in math we use the letter K. Now don't mix this K with this K. This is a direct variation. This is an indirect variation or an inverse variation. And so they're not going to be related. And so to even use the K, you're going to have to know if it's a direct constant or an indirect constant. Now with the direct constant, what we have is one variable over another. Therefore, the bigger M gets, the bigger N is going to get. And that sounds normal. It's, you know, the more you have of one thing, the more you're going to have of another. And we'll get into some problems that deal with that. And the inverse relationship is this, y times z. Now if you think about it, as y goes up in value, z is going to go down in value because we're multiplying two things and it has to equal the same constant. Whereas over here, it's one number over another number, so we don't have to worry about them both going up in value. Let me show you a couple of examples. Let's say I tell you that the value of m is 8 and the value of n is 2. By the way, that would make a constant, the k, equal 4. But I'm going to increase the value of 8 to 16. That is, I'm going to double it. So what am I going to do with 2? I'm going to double that. So they vary directly. Every time I double m, I'm going to double n. If I make m 16 times as big, I'm going to make n 16 times as big. And I'm going to use a constant to do that. And just wait and I'll show you how to use that k. But inversely, it works just the opposite. If I tell you that our inverse constant, k, equals 8, let's try out some numbers. I'm going to say that y equals 1. That's going to make z equal 8. Now let's double y. Well, if we double y, we're not going to double z. Remember, our constant is 8. Constant means it doesn't change. Either one of these, okay? When we're varying directly, the k doesn't change. When we're varying indirectly, the k doesn't change. So it's always going to be 8. So 2 times what is going to equal 8? Well, y went up in value, but z went down in value. And that's going to continue as y gets larger. I doubled y again, and I'm going to cut z in half again because they vary inversely. The bigger this gets, the smaller this gets. Now, as you can see, I'm doubling y, and I'm doing that for convenience sake. Y can go up by 10% or 15% or 23%, whatever you want, and it's not going to make any difference as long as we multiply it by z and it equals 8. Okay, let's get into a couple of problems that I think will make this a lot easier. And before I do, Mr. Wallace has included in this lesson some information on joint variation or jointly proportional variables. And he also includes variability as to the square. I believe those two variations are Algebra 2, so we're going to exclude that from our lesson here. And you can also exclude that from your homework because I'm not going to give you a test on those two variations. But this is what kind of variation? One variable over another variable. What kind of a variation is that? That's a direct variation. Okay, anytime you see we're looking for the constant, but we have one variable over another variable, that's directly proportional. The price of an item varies directly with the sales tax. If a $25 item has a sales tax of $2, what will be the tax on a $40 item? And in this case, we're going to have price and tax. Let's say we sell $25 worth of goods. And when we sell $25 worth of goods, we're going to charge $2 in taxes. So our constant for goods or our constant for taxes, 12.5. So that's the constant that we use. We want to figure out how much we've sold. You can look at how much tax you've collected and figure out how much you've sold. Or you can look at how much you've sold and see what to charge in taxes. And that's our original formula, except that we're not selling the same goods, so the P isn't the same. Let's change that P and that tax to P2 and T2. Yeah, I hope you can see that. And the reason why I'm doing that is that the price of the second thing that I'm selling is not the same price as the first thing I'm selling. And the amount of tax I'm charging on the first thing is not the same as the second thing. But our constant is not going to change. Our constant is always going to be 12.5. Now it's always going to be 12.5 for this store. Another store may have a different tax rate, and certainly when you move to different states, we're going to have different tax rates. But at least for this store, we know that our K is always 12.5. So let's say that he sells $40 worth of goods. Okay, now we can solve for this because we only have one variable. When you have an equation with several variables, if you eliminate the variables down to just one variable, we can solve for that. And since we're trying to get T2 alone, we're going to multiply both sides by T2. That is to say, we need to get the T2 off the bottom, right? So how do we get it off the bottom? We multiply the top times T2. And whatever we multiply the left-hand side by, we need to multiply the right-hand side by. T2 over T2 is 1. And 1 times 40 is 40. And we've got our T2 off the bottom, but it still has a coefficient. So why don't we divide both sides by 12.5? 12.5 divided by 12.5 is 1. 40 divided by 12.5 is 3.2. And since we're talking about money, T2 equals $3.20. That is to say that if we sell $40 worth of goods, we're going to charge $3.20 worth of taxes. Now you see that I have that T2 there because that's the amount of tax for the second thing we sold. The first thing that we sold had a different amount of tax. And so let's see what happens when things vary inversely. Okay, now we have a problem that varies inversely. When you have two variables, R and T, that are multiplied by each other, not divided by each other, but multiplied by each other, we're going to have an inverse relationship. And I showed you before that when you tried to multiply 1 times 8, you only had to multiply 2 times 4. and you only had to multiply 4 times 2, and the second number kept getting smaller as the first number kept getting bigger. And the inverse is the truth, is as this number gets smaller, this number is going to get bigger. But our constant is going to always be the same. Now in the problem that we're doing here, our t have specific entities associated with them. R is speed. Now the reason why we use R, that's a very common thing in math. We use R for speed. R stands for rate. So if you can associate rate with speed or velocity, that's what it stands for. T stands for time. Now that's usually in hours, but it doesn't have to be. And the constant is going to always be the same for this person who is associated with this problem. And the k in this instance is going to be his distance. It's going to be his distance to work. The speed or rate Josiah travels to work is inversely proportional to the time it takes to get there. If he travels 35 miles per hour, it will take him 2.5 hours to get to work. How long will it take him if he travels 55 miles per hour? Our friend Josiah is traveling to work, and he likes to travel at 35 miles per hour. And when he travels at 35 miles per hour, it takes him 2.5 hours to get to work, 2.5 hours to get to work. So how far is it to his work? It is 87.5 miles, or 87.5 miles. And the constant here is very valuable because his workplace is always going to be in the same location, and his home is always going to be in the same location. So the distance to his work is always going to be the same. But he wants to know how long it'll take him to get to work if he drives a little faster. When he was first traveling to work, he liked looking at all the pastures and the cows and the mountain peaks. But after a while, he thought he wanted to spend less time in the road. So he is going to drive at 55 miles per hour now instead of the 35. Let's see if he gets to work quicker. To get T2 alone, we're going to divide both sides by 55, and 55 over 55 is 1. 1 times T2 is T2. 87.5 miles over 55 miles per hour is 1.59. 1.59 what? Hours. 1.59 hours. Now, where did the hours come from? Well, when we put our numbers up, Mr. Wallace likes to do this the way I do. Instead of putting all those hours in miles per hour and then crossing them out as you divide, it can be very confusing, and I think it gets in the way. Now, when we're talking about time, we know that the answer, at least in this case, is always going to be hours. And if we're talking about his speed, it's always going to be miles per hour. It's not going to be kilometers per hour. It's going to be miles per hour. And if we're talking about his distance, we're always going to be talking about miles. So when we finally get our answer, let's associate it properly. And 1.59 for time is going to be associated with hours. It's going to take him 1.59 hours to get to work if he drives faster. So as you can see here, we had T2, not the T1 we had before. Now let me show you a different way to do all this. Now we're going to solve the first problem by setting up a proportionality instead of a constant. Now I believe this is a lot easier. The problem with this is if they ask for a constant, well, you have to go back to the original way of doing things. But as you can see, I've set this up for P1 over P2 equals T1 over T2. Okay, so the price of the goods sold the first time over the price of the goods sold the second time equals the taxes of the goods the first time to the taxes of the goods the second time. The prices of the goods sold the first time was $25. The second time it was $40. The taxes the first time, T1, was $2. So what were the taxes the second time? Now there's two ways to solve this. You already know how to solve this the old way. I'm going to show you a new way. We're going to cross multiply. And so the product of the means equal the product of the extremes. So we're going to do 25 times T2 equals 2 times 40. I think it's a lot easier to deal with proportionalities this way. If you don't like that, you can go back to the old way of doing things. We're probably going to have to get into the product of the means equals the product of the extremes later, but this is one way to do it now. And you probably already learned this in the 8th grade. Anyways, 2 times 40 is 80, and we're going to divide both sides by 25 to get T2 alone. And 25 over 25 is 1, and 80 over 25 is 3.2. We're going to charge them $3.20 in taxes. Okay, let's see how the inverse proportionality works. Okay, let's try our speed problem using the same type of methodology. We have R1 over R2 equals T1 over T2, but that's the way to solve a problem with direct proportion. What we're doing here is inverse proportion. So we're going to have to invert T1 and T2. There we go, and the first rate that they gave us was 35 miles per hour. And the second variable that they gave us was 2.5 hours, which was the first time, or T1. And they asked us to solve for the second time, T2, if they gave us a rate of 55 miles per hour. Now let's solve this by cross multiplication. Let's multiply 35 times 2.5. And that's going to equal 55 times T2. 35 times 2.5 is 87.5. And we're going to divide both sides by 55, which will leave us with T2 on the right-hand side. And it will leave us with 1.59 on the left-hand side. So the second time is 1.59 hours, just like it was the first time we solved this problem. And that is it. Whichever methodology you like, Mr. Wallace does it one way, I do it another way. And whichever you find is the easiest way to do that is acceptable. And if you do your homework, we'll be ready for the next lesson.